Starting this thing. All right, practice test 2. I gotta see where we left off. So we are ready for problem number 7. All right, so here we go. If you get an A on the test, I'll let you sing and dance all you want.
Oh, you're right, you're right.
Quiet and focus.
You're right.
Okay, so we're gonna sketch this guy. So the first thing I remember is that he is a tangent. And tangents have an asymptote and an asymptote, and normally a squiggly line up through the origin. But because of the negative, I'm going to have my squiggly line coming down through the origin. Right? Normally, my asymptotes are at negative 90 and 90. Well, look at that guy right there. He's going to divide. So negative 90 divided by a half is negative 90 times 2.
Yep.
So negative 180 and positive 180. So my amplitude doesn't exist.
Yep.
My period, negative 180 to 180, is 360 degrees. All right, now I got a sign. What do I remember about signs? Well, they start at the origin and have a hill and a valley. Normally, the hill goes up to 1 and down to negative 1, and that's exactly what this one's going to do because there's nothing out in front to change it. So the amplitude is 1. Normally, the labels for the top of the hill, where we cross, the bottom of the valley, and where we end, are 91, 82, 73, 60. But those numbers have all been divided by 3. This number is a divider. Right?
Yeah.
So what are the new labels then? 30.
60, 90, 120.
Yep. So my period is 120 degrees. Right? Easy. Now I got a cosine. Cosines start at the top of the hill, so make half a hill, and then a valley, and then the other half of the hill. They end at the top of the hill. Just where they started. Normally, these vertical labels are 1 and negative 1. But this time, I've got a multiplier out here, so they're 5 and negative 5, which means my amplitude is 5. Just like with the sign, the normal labels are 90, 180, 270, and 260. But this time, they've been divided by 4. So the new labels will be 22 and a half, 45, 67 and a half, and 90. So my period is 90 degrees. Okay, you're going to have to do this on test day. calculators out. And we're gonna do exactly what we did yesterday, because we know all the practice tests are the same and they are exactly like the real test. So 287.175. The calculator, 287.175. Second apps VMS. 287 degrees, 10 minutes, 30 seconds. No partial credit. We are right or we are wrong. All right, everybody got that?
Yep.
Perfect. Now, we have our calculator problems. And who remembers the advice I gave you about doing these calculator problems? Yeah, do degrees, do all the degrees and all the radians, and it doesn't matter which you do first, but do all of one, so you're not constantly switching back and forth. So do you want to do the degrees or the radians first?
Degrees.
Degrees? All right, so which ones are the degree problems?
B, D, and F.
D and F. There's 3 degree problems,
Yes.
right? All right, so make sure my calculator's set in degrees. And then how do I do a cosecant on letter B? Cosecant is 1 divided by sine, 183 second apps degrees, 21 second apps minutes, and 3 alpha plus. And oh wow, did you get negative 17.1087? 10,000, 3 decimal, or 4 decimal places, 4 decimal places. Okay? Yeah. All right, next is D. Here we go. Tangent. 321 second angle degrees, 58 second angle minutes. For D, I got negative 0.7822. Wait, should we be just copying these down? No, we should be typing these in. Keaton, you typing them in? Okay. And the last one, F, secant 23. 1 divided by cosine 23. 1.0861. All right. Now what do we have to do? Change our calculator, go to mode, highlight radians, and then start in. So A will be second tangent, 1.375, 0.9420, 0.9420. That look okay? Cameron?
Yes.
You got that?
Yes.
Did you type it in? If I come back there and look on your screen, I'm gonna see that?
Not no more, no. Not anymore, no.
You know, I can still go back and see what you had. You better type that in. That is not right. No, not good enough. What was the problem? Okay, now this is the one, that was F, and you got F right. We are on this one now, you didn't do that one. So you need to change your calculator into radians. Sit up and stay awake, okay? Our calculator needs to be in radians now. All right, C, easy. Cosine 1.75, negative 0.1782. For C. And then E. We're not worried, we're gonna type in exactly what we see. We're gonna type sine 18 second pi, pi is underneath your clear button, divided by 77.6701. You don't need to put any parentheses, you don't need to put any equals, you just type in exactly what you see. And then hit it. You get it? Good work, Cam. All right, how is my calculator set right now in radians? Let's look at problem number 10. What do you see down there in that corner? A degree sign. So we need to go right now and change our calculator back into degrees. Was anybody listening to me yesterday when I said the entire test, the calculator part, is in degrees, except for this section right here, right? So pay attention to how that calculator is set up, because you know you'll get the wrong answer if you're in the wrong mode. All right, here we go, part 10. Okay, every time we do this, we come up with an equation, tangent, sine, or cosine, every time. So when I look at this problem, I have opposite and adjacent.
Tan.
Tan. So tan x, it's always tan angle. Don't ever say tan 8. No, the angle goes with the tangent. So tan x equals opposite over adjacent. Now, if you multiply by 9, you will be wrong. What do we do when we're trying to find the angle? Inverse. So we're going to inverse tangent 8/9. That happens in our word problems too sometimes. If you are looking for an angle, second tangent 8/9. 41.63. 41.63 degrees. This picture does not look like our normal word problem pictures, and that's okay. Whatever the picture is, that's what it is. When we're doing our word problems, they always look like this, right? But if we're given a picture, we have to use it. So this is the picture we've been given. This will be a sign, and it will be a sign because this side right here is the opposite, and this side right here is the hypotenuse. So sine 63 equals 12 over x. Now, am I going to be using this button? No, because I know my angle. I only use that button when x is the angle. So here I will multiply by x and divide by 12. And type it in. 13.47. Okay, friends? All right, here we go. Draw a course of 310 degrees. This is so easy, but you have to remember that when we're doing a course, these are our labels, right? So if you know that, then this is easy. Where's 310? Somewhere over here, right? So we draw our angle and mark it 310 degrees, and that's it, we're done. Now we have the problem that we are going to do twice. Remember that exact means by hand. And decimal means with the calculator. So we're going to do the same problem twice. The answers are going to look different, but they're going to be the same. All right, calculator is the easiest. Let's type it in. Cosine second sine 1 divided by 3. Decimally 0.9428. Cosine inverse sine 1/3. Remember, we're not worried about what it looks like. We're just typing in exactly what it is. Type it in. All right, everybody got that?
Yep.
Okay. Now we're gonna do it by hand. Okay, remember what you do if you do it by hand? You draw a picture, right? That is a positive number right there. So I'm gonna draw this picture in quadrant 1. This tells me, remember I'm not doing this part. I'm looking at just the parentheses. This tells me that the opposite over hypotenuse is 1/3. Right? So what do I need to do? Pythagorean theorem. So a squared plus 1 squared equals 3 squared. Remember, the hypotenuse is always c. A and b don't matter, but c is the hypotenuse. So what do you get for a? Square root of 8, which we are going to write as 2√2. Because 8 breaks down into 4 times 2. The square root of 4 is 2, so 2 radical 2. Now, I want to know the cosine of that picture. So the cosine will be 2 radical 2/3, adjacent over hypotenuse. Now, if I'm not sure and I want to check my answer, if I type this in on my calculator, isn't this what I should get? All right, just remember, when you type 2 radical 2, you need to close those parentheses before you hit divided by 3. And sure enough, we got it right. Okay? Now we got our word problems. I think I told you yesterday, I meant to tell you that the test will only have 3 word problems on it. I just put extras on here for extra practice. All right, oh, guess what we have? A squirrel in the top of a tree. And I bet he is looking at a nut on the ground. Okay. He's looking at a nut on the ground that is 52 feet away from him. Hypotenuse, 52. Squirrel, nut, 52 feet away from him. The angle of depression is 17.7 degrees. find the height of the tree. Picture all right with everybody? Sine, cosine, or tangent? Sine. Sine 17.7 equals opposite over hypotenuse. The answer will be whatever 52 sine 17.7 is. Do you get 15.81 feet? In our word problems, we always put a unit on our answer. Any question about that? All right, go ahead and do B on your own with your partner now. Let's see what we come up with.
He has two wives and we've never seen him with a girl. Fish in the water from 100 feet from the shore. Spotted. So the fish is on the bottom. And then the seagull on the jelly. Seagull at the top. From 100 feet. Alright.
How does my picture look compared to yours?
Yeah.
Sine, cosine, or tangent?
Tangent.
And when you wrote your equation, it was 10x, right? And when it's 10x, that means I do not multiply by 100. I go straight to my calculator and inverse tangent. So inverse tangent, 12 over 100, you get 6.84 degrees. All right, here we go. These problems all mold together here. We have an airplane
You've been on an airplane before?
approaching an airport. Find the desired angle of descent. Now remember, angle of descent would be angle of depression going down, but the angle of depression and the angle of elevation are always the same, and they're always right here. All right? The pilot wants to land at a point that is currently 7,000 feet from the plane. Hypotenuse. And the plane is 235 feet above the ground. Sine, cosine, or tangent? Sine x equals 235 over 7,000. What do we type it? Inverse sine. Second sine, 1.92 degrees. Right? Find the height of a flagpole that makes a shadow 16.62 feet long when the angle of elevation is 64 degrees. Tangent 64 equals x over 16.62. X equals 16.62 tangent 64. Alright. So 16.62 tangent 64. Did you get 34.08? Feet. And finally, we got the man looking at the top of the building. The building is 48 feet tall, and the man is standing 3,000 feet from the top of the building. Hypotenuse. What am I looking for? The angle. Sine. Girls over here, sine. So sine x equals 48 over 3,000. What am I going to type in? Inverse. So second sine, 48 over 3,000. Wow, this is a little one, 0.92 degrees. Zion, zip it. All right, so we're going to save practice test 3 for our last class before our test, so we'll just hang on to that. And what I'm going to do now is hand out your notes and homework for chapter 5. So I am going to preface this by saying, for most students, 5.1 is the hardest thing we do all year. So, you will find it a little bit difficult. You'll find it a little bit confusing. But as we practice, like everything else, as we practice more and more, it will get easier. Will it ever get easy? I don't know. But it will get easier with practice. What we can't do is get started on this. Yeah. What we can't do is immediately give up. You can't give up. You have to stay tough. Alright? So, you're going to get notes and homework. And then I'm going to give you a new reference sheet. In chapter 5, we only do, looking at our textbook, we only do 3 sections in the whole chapter. 5.1, 5.5, and 5.6. The real hard stuff is in some of the other sections. The 5.1 is all right, everybody has notes and homework. Here comes your new reference sheet. Please do not lose this. And I'm going to have you right now mark a couple of things on it. This is a reference sheet for the entire chapter. I told you we don't do the whole chapter. So we're gonna circle the parts that we need on this sheet.
You guys have like a wager on what? Yeah.
What is this? What am I looking at?
What?
All right. So here's what I want you.
What am I looking at?
Here's what I want you to circle on your reference sheet, okay? On your reference sheet, up here in my handwriting, it says tan theta equals sine theta over cosine theta. Circle that. You're gonna use that a lot. Okay? Then, right underneath where it says chapter 5 reference sheet, there's this little group of 3 equations. Sine squared plus cosine squared, 1 plus cotangent squared, and 1 plus tangent squared.
Yeah.
Circle those. Those are called the Pythagorean identities. Okay? Now, I don't think we will use anything else on this sheet. Alright, so I don't want you to be overwhelmed when you look at it. We are going to be using the 2 circled parts. Got it?
Yes, ma'am.
Now the rest of it's there in case we run into something, but we're probably not going to. All right. Huh? Yeah. So what are we doing here? Oh, that is a great question. Our job, I'm in my notes now, 5.1. And it's still trigonometry, so it's not completely off base from what we've been doing. It's just an extension of it. The directions say simplify. Now, traditionally, mathematicians, this is sine cubed. That means sine x cubed. Traditionally, we write it this way because we either have to use parentheses, and no one wants to write those over and over again, because we can't write it this way. Do you understand why we can't write it this way? Then it looks like the x is cubed, and that's not what I mean. I mean the sine is cubed. So when we see this, it means this. And so similarly, this means this. Now, if you want to write it this way, that is totally fine. I will never. No one else will, but it's okay. It's not wrong. This way, I don't need parentheses. This means the sign is being cubed. All right? Now, directions say simplify. I want you to think about what you would do if you had a problem that looked like this. What could you do if you had a problem, a cubed plus ab squared? What would occur to you to do there? You can't add these. Factor. And what would you factor here? You take out an a. So when I look up here, this is sine cubed, and this is regular sine. So I am going to take out or factor out a sine. When I said that, I said I'm going to take out a sine. SIN never does anything without an x attached to it. So I'm actually taking out sine x. Even though I won't keep saying the x, I'll just say sine. This is 3 sines right here. if I take out one of them, I'm gonna have two signs left. It's just like down here. If you took out an A, wouldn't you have A squared left? Same thing. I'm taking out one of my signs. I got two left. Now, plus what? I'm taking out a sign, so what am I gonna have left? Cosine squared. Now, my heart is jumping for joy. Look on your green sheet. Is there anywhere where you see a sine circled, where you see a sine squared plus a cosine squared? What does that equal? 1. Oh my gosh. This right here equals 1? So all I have left is my sine times 1, which is sine. So remember what the directions were. Simplify. We started with that big ugly thing, and it all reduced down through factoring. It reduced down to sine, Okay, isn't that cool?
Did the parentheses just went down to what, like?
Power went down 1 because I factored, yep.
Sean.
What?
Sorry.
You just decide, I'm just gonna
Sean.
Okay, that is a great question. And so I am gonna show you, why it's 1, but I'm not gonna prove all the rest of them. It takes too much time. These are all this stuff on here is provable. They can all be derived. They aren't made up. They're real legit things. But this one is the fundamental trigonometric identity, so I'll go ahead and do it. So, I'm gonna call that angle theta. Would you agree with me? Angle theta. I'm gonna call this x, and this y, and that r. No, I'm proving the I'm proving this identity. It's probably good that I prove one of them, just so you understand these aren't made up. Grayson said, who just decided sine squared plus cosine squared is 1? Well, no one just decided that. It's provable. We're gonna prove it, okay? So, actually, let me do this so it makes more sense to what we're doing now. Let me draw my triangle with this. So there's theta, x, y, and r. Does that make sense to you? Right? Now, do we know for a fact that x squared plus y squared equals r squared in that picture? Do we know that? Because that's the Pythagorean theorem, right? No one's gonna argue with that. Now, I'm gonna take this equation and I'm gonna divide everything by r squared. Now, that is legal. I can divide everything by the same thing. So now I have x over r squared. I have x squared over r squared, which is the fraction x over r squared. And then I have the fraction y over r squared. Okay?
Mm-hmm.
And then r squared over r squared is just 1. Think of your green sheet now. Kids, what's x over r? Cosine. Adjacent over hypotenuse, that's cosine. Y over r is sine. And there it is. There it is. Every single thing on this sheet can be figured out this kind of way, okay? So please, no one ever thinks this is just made up stuff. It is not. It all came from somewhere. Okay? Now, while I'm at it, cute story about this identity. This is a biggie. It is literally called the fundamental trigonometric identity. All right, fundamental trigonometric identity. A couple summers ago, 3 summers ago maybe, we were talking about bringing AP pre-calculus to Cathedral. It was a new course, never been done before. There was a conference here in town, so I said, I'll go. Let's see what this is about. Let's see if we should be doing this. In the end, we do it now. We've had great success. It's been a wonderful thing. But we were just kind of exploring that. So I go to this conference. It's all day, 5 days a week, 8 hours a day, and all we do is pre-cal. It is amazing. Okay. So the teacher, awesome guy. I don't know if you noticed, you probably didn't even notice, but when they decorated my door and they put all the math teachers on my door at Christmas time, the guy in the middle with the Santa hat is the guy who led this conference. He is amazing. I talk about him all the time. I use his stuff constantly. But anyhow, he's up there teaching with summertime, and on his arm, tattooed, he has cosine squared theta on his arm. And one of the guys in the class finally got up courage to say, "Hey, Brian, why do you have a tattoo that's cosine squared? And what's the significance of that?" Stand up here next to him. He said, he said, now remember, he's got cosine squared right here, okay? He said, my wife has sine squared right here. So when we're walking down the street holding hands, it's cosine squared and sine squared. And what does cosine squared and sine squared make? 1. I think it's an amazing story.
I didn't assume this for they just hate it.
I know. And then I'm jealous because I never thought of that. But I would never get a tattoo anyway. But I thought that was really cool. All right. Let's do another problem. All right. Number 2.
Next Monday.
Your job is to simplify. So just kind of look at this problem. What is something you could do?
Did you cancel?
No, these are being multiplied, not added. So since they're being multiplied, couldn't we FOIL? Why don't we FOIL? So we have secant squared, I'm FOILing, minus secant plus secant minus 1. So just first times first, second times second, or first times first, outsides, insides, and last, right? Again, when I said it, I said secant, but I meant secant x. There's always an x before your secant. Okay? Never write just S-E-C. You have to have an x on it. All right, now, do you notice anything? I'm not doing anything at the bottom right now. Do you notice anything with the top?
Yeah, you can.
Now, they do cancel because now it is an addition problem. Right? So we have secant squared minus 1 on the top over sine squared. Now I want you to look at your green sheet and the circled parts. Is there anything that involves, in some way, shape, or form, a secant squared and a 1?
Yes.
Yeah, it doesn't look exactly like that. What does it say? 1 plus tangent squared is secant squared. All right, now, if I take that, which is on my green sheet, and I subtract 1 from both sides, what will it say? Tangent squared equals secant squared minus minus 1? Now you can add that to your green sheet if you want, this right here. It's the same as this, but it looks a little different. So if secant squared minus 1 is tangent squared, then isn't my numerator just tangent squared? This right here is this right here. Right? Secant squared minus 1 is tangent squared. Write that down. Every time you see a secant squared minus 1, you're going to replace it with tangent squared. Remember, we're trying to simplify it. Now, what can you tell me about tangent? I know you can tell me lots of things about tangent, but in terms of what's on the green sheet,
It's
or
y over
whatever your
x.
sheet is, your identity sheet,
Just sign over cosine.
sine over cosine. So I want you to look up here, guys. This is the last problem we're going to do, but I need you to stay with me. This literally says tangent squared divided by sine squared, right? Tangent squared is sine squared over cosine squared. Mrs. Ford, how do you know that? It is circled on your paper. Tangent is sine over cosine. So I have tangent squared
Right.
divided by sine squared over 1. So I'm going to take sine squared over cosine squared and keep change flip 1 over sine squared. So I have my tangent right here divided by my sine. So I'm going to keep change flip that. And these are going to cancel. And what am I left with? 1 over cosine squared, which is secant squared. Remember, 1 over cosine is secant. So that guy simplified down to just secant squared. 1 over cosine is secant. The reciprocal of the cosine is secant.
I take a picture so I know it's saying this thing.
I kind of really turned it. Is this your stuff over here?